All right, hey guys, this video is going to introduce us to our next lesson, which is solving equations by factoring, which we've kind of already introduced you to, so hopefully this will formalize it and you'll feel a little bit better about it. So I'd like you to go in your notebook. You could go to the back of your notebook, or you could make a page in your notebook and just give it this title, Solve by Factoring, Lesson 11.4, and just do all the problems, and you'll have lots of examples. So those are your two options, but you do need to write these problems down. You're also going to be solving several problems, and you're going to be submitting a screenshot of your notes. So make sure you are taking them. Again, you are going to be submitting a screenshot of the problems that you tried. So make sure you have something to write with right now. All right, so we're going to be solving equations. Again, these are called quadratic equations. Any equation with a squared on the exponent is called a quadratic equation. And by the end of this lesson, hopefully we can come up with a strategy to solve this equation, these two equations. So we've learned how to complete the square as an option to solve an equation that looks like this. We've learned we could solve it by graphing, but today we're going to solve it by factoring. So by the end of this lesson, you should be able to solve these two types of equations. So first thing, I want you to pause the video. You don't need to write these ones down, but I want you to think, what would the answer to each of these problems be, and why would it be that? So go ahead, pause the video, and just think about what you think the answer is. All right, so hopefully after you pause the video, you came up with an answer of 0 for the first one. 5 times 0 gives you an answer of 0. -8 times something, well, that would also have to be 0. 3 times 2 is 6. 6 times what is 0? Well, again, it'd have to be 0. This one, 5 times 4 times something times 10 is 0. Well, you'd have to have 0 as a number. And then if I did 4 plus 3, that's 7. 7 times what is 0? Well, again, it would have to be a 0. This is called the zero product property. Okay, so that basically says if you are multiplying two or more numbers, and if you want the product or the answer to be 0, then one of the numbers has to be 0. Okay, so one of the factors would have to be 0. So if I did 5 times something is 0, one of the two factors, if the answer is 0, one of these two things must be 0. So that's going to be important for our lesson today. Okay, so let's take a look at these equations. If I asked you to solve them, I just want you to try them and see what you would get for each of them. Okay, you might notice that all of the answers are 0, so think about what I just talked about. So pause the video. I'd like you to try all 4 of these somewhere in your notebook or in your notes. All right, so this first one, this is saying 5 times something is 0. Well, if you wanted to solve it this way, you could divide by 5, and I end up with 0. If I wanted to check it, 5 times 0 is indeed 0. Same thing here. If I wanted to solve for y, I could divide by -8, but I still end up with y equals 0. Again, a quick check, -8 times 0 is 0. Okay, on this last one, you probably could have thought about this 2 different ways. So one way I think about it, and I'll show you guys this in class tomorrow, is I kind of just cover this up. If I had my hand here, I would cover this up with a box. So I would say, well, 6 times something is 0. Well, that means inside this parentheses, it needs to be 0. Because if I get a 0 in here, then 6 times 0 would give me 0. So I want you to think about what could make this equal 0. Again, this is kind of called the cover-up method. So if I plugged in what could make this equal 0, something minus 4 is 0. Well, m would actually have to be 4. So again, quick check. If I do this, 4 minus 4 is definitely 0. 0 times 6 is 0. Now, if you solve that the long way, you could distribute, and you could say 6m minus 24 equals 0. You could add 24. 6m equals 24. You would get m equals 4. Same way we just got it. So if you look at the second one, think about it the same way. So I learned with the zero product property, if I have 4 times something, whatever this is, has to equal 0. Well, if the answer is 0, one of the two factors has to be 0. So this one needs to equal 0. So I want to think, what could I plug in for C that would get to equal 0? What kind of think in your head? 2 times something minus 6 would give you 0. If you're not sure, you could solve it. Okay, I would add 6. I get 2c equals 6, and then c equals 3. So my solution here is c equals 3. Again, if I plugged in a 3, I would get 2 times 3 is 6, 6 minus 6 is 0, 4 times 0 is indeed 0. Okay, so think about how we just solved the last ones, and I want you to see if you can come up with a solution for these two equations. So go ahead, pause the video, and just think about what we learned. I'm going to give you a hint. Don't multiply it out, because if you multiply this out, you're going to end up with a squared plus this. You're not going to be able to solve that. Well, actually, this one you could solve. But I want you to see if you could solve it using what I just talked about. Okay, so you should have paused the video, kind of tried it. So if the answer is 0, that means either this factor here or this factor here has to be 0. Because if this outside was 0, 0 times whatever's here would be 0. Or if inside here was 0, then 0 times whatever's out here would also equal 0. So I want you to think, well, what could make this parentheses equal 0? Well, what if I put a negative 2 there? If y was negative 2, then I would have negative 2 plus 2 times 5 times negative 2 on the outside. Well, this is 0. 0 times, I don't even care what that is 0. That's actually one answer. There's actually another solution. Okay, think about out here. What could get this to equal 0? Because if this was a 0 out here, 0 times whatever that whole thing is would give me 0. Well, 5 times what is 0? 0. So my other solution is 0. And again, I could plug that in. I could say 5 times 0 times 0 plus 2, does that equal 0? Well, this is a 2. 5 times 0 is 0. 0 times 2 is 0. So my two solutions, I actually have two solutions for this one, are 0 and negative 2. Okay, if you want to retry the second problem, go ahead and try it out or think to yourself, what would the answers be? So again, if the answer is 0, then that means one of these two factors has to be 0. So what could I put here to make the answer equal 0? Well, if x was just 0, I would have 0 times 0 minus 3. Well, 0 times anything is 0. So 0 is one answer. And then inside the parentheses, I'm going to think, well, what would make this equal 0 inside here? Well, what if it was a 3? Right? Because if I had 3 minus 3, that's 0. And then 0 times that is 0. So my second solution is x equals 3. So those would be my two solutions to that equation. Okay, now if you look at these next three, you're going to notice that they all equal 0 again. Okay, so again, equals 0, equals 0, equals 0. So I need to figure out, well, what could I plug in for a that this would equal 0? Now, if I just looked at this first one, I'd be like, okay, I don't even know where to start, because if I plug in a 0, well, 0 would definitely work here. Okay, so that's probably one of my solutions. But there's probably another one. If you notice, our other ones had two solutions. So quadratics can, we've learned this already, can have two solutions. They could have one solution, or some of them have no solutions. And we talked about that when we had a graph, right? Solutions are kind of like x-intercepts. So they could have no solutions, they could have two solutions, or they could just have one solution. So if I think of this, it could just have one, but how do I know for sure without graphing it? So if you think about our last ones we just did, we kind of wrote them like this. If we get it factored, it's going to make it a lot easier to solve. So if I try factoring this, okay, so let's look at this. Is there anything I can divide out of both of those? Well, greatest common factor is 2a. So I'll give you a second to rewrite that. Okay, so rewrite it using the distributive property. It'd be 2a times 5a minus 4 equals 0. So again, now I know that either this needs to be 0, what I highlighted in green, or what I highlighted in pink inside here needs to be 0 for it to have an answer of 0, right? Because 0 times something is 0, or something times 0 is 0. So now you just have to figure out, what could I put in for a? Well, this one's easy. What would make that equal 0? 2 times what is 0? One solution is a equals 0, which we already knew about. How about in here? How could I get this to equal 0? Something minus 4 equals 0. Well, it's got to be 4 minus 4, right? So how could I get this to be a 4? Well, if you're not sure, just set this equal to 0. So when would 5a minus 4, when would that equal 0? I'm going to add 4. I get 5a equals 4. I'm going to divide by 5. I get a equals 4/5. That is my second solution. So I have 2 solutions for that one. Okay, let's try the one below it. So I'm going to try it in a different color so you can see it a little bit better. Let's try this one. All right, so first thing I would try to do is factor it. So I see they both have a x as their greatest common factor. So it'd be x times x minus 3. So again, trying to make this very explicit, either this needs to be 0, what I'm highlighting, or inside here needs to be 0 for the whole answer to equal 0. Well, what could that x be here? Well, if that was a 0, 0 times this would be 0. So one solution is 0. And then what would make this equal 0? Well, 3 minus 3 is 0. So x equals 3 is my second solution. Okay, I'd like you to try problem number 3 up here. So pause the video and see if you can come up with a solution or solutions. Okay, hopefully you had a chance to try it. So the greatest common factor is 4 and k. So 4k. So if I do 4k times k would give me that, and minus 3 equals 0. So again, what would make this equal 0? Well, 4 times 0 would give me 0. And what would make this inside here be 0? Well, I would need this to be a 3, because 3 minus 3 would be 0, so k equals 3. Those would be my 2 solutions. So we just solved this by factoring, because you can see we factored it first. We had it set equal to 0. We could quickly find the solutions. Now, again, if you wanted to test that this was right, you would just come back and plug this in. I would do 4. I would plug in a 3. I'll just test that one. Minus 12 times 3. Okay, so I'm just doing a check for you guys. So 3 squared is 9. 9 times 4 is 36. Minus 12 times 3 is 36. 36 minus 36 equals 0. So I know this one is correct. I could do the same thing with 0. I'm not going to check it, but it does work. All right, so if you think about this, if I gave you this problem, what could you tell me must be true? What would you say must be true to get an answer of 0? What would you tell me? Well, hopefully you would say, well, either whatever's inside here or whatever's inside this parentheses, one of them must be a 0, right? Because if this was 0, 0 times whatever is definitely 0. Or if this one was 0, 0 times something would definitely be 0. So again, if you're multiplying things, one of the factors must be 0 for the answer to be 0. All right, so if we have one like this, it looks a little bit different now. So obviously somebody factored this already, this equation. And I want to know, when would this equal 0? So we just talked about this parentheses or this parentheses has to equal 0. So what would make this equal 0? Well, something plus 4 is 0. X would definitely need to be negative 4. Now, if I did that, negative 4 plus 4 is 0. 0 times this is 0. Okay, what about this parentheses? What would make that equal 0? Well, if I plugged in a 3, 3 minus 3 is 0. Now 0 times this first thing is 0. So those are my 2 solutions. All right, now they get a little bit harder. So I'm going to have you pause the video, and I'm going to see if you can try these 2. What could you plug in so that it equals 0? All right, hopefully you had a chance to try this. So again, I'm just going to keep saying this, and hopefully you got it. If the answer is 0, either this parentheses or this parentheses, one of those has to equal 0. Because 0 times something is 0. This one's the easy one. Hopefully you got x equals 1. Because 1 minus 1 is 0. 0 times whatever this is 0. That's a question mark. But what would make this equal 0? Some of you can kind of probably think of this in your head like, hey, if this is 8, this part needs to be negative 8. But if you can't, here's what I just like to do. I just like to say, hey, when does 2x plus 8, when does that equal 0? Just set up a little equation. Subtract 8. I get 2x equals negative 8. So x equals negative 4. So one solution is 1. The other one is negative 4. All right, second one. These ones both were a little bit trickier. So if I start with the first one, when does this equal 0? So I can say, okay, 4x minus 2. What could I plug in so it's 0? I would add 2. I get 4x equals 2, and then divide by 4. So x equals 2/4, which is the same as 1/2. There's one solution. Second one, when would this parentheses equal 0? What could you plug in here so that this whole thing is 0? So 2x plus 5 equals 0. 2x equals negative 5 if I subtract 5. Divide by 2. x equals negative 5/2 or negative 2.5. So if you plug that in here, you would get 0, and then 0 times this equals 0. All right, so our next set of problems is going to look like this. And I apologize, this is kind of a long video, but got a lot to go through. So now if it looks like this is going to be hard to figure out, like, hey, what can I plug in that equals 0? I can't just do this in my head. So I'm going to use the strategy solve by factoring. So I'm going to try to factor this. Okay, so again, if there's no coefficient, it's a little bit easier to factor. It's going to be x and x. And then what times what is negative 8, but when you add, you get negative 2. So if you need to make a little thing, you can put negative 8 and negative 2 down here. That looks like it would be a negative 4 times 2. Yep, so it'd be x minus 4, x plus 2. So I just factored that. Now that I have it looking like that, I can figure out what could I plug in here to make this 0, or what could I plug in here to make this 0. So in the first one, if I plugged in a 4, 4 minus 4 is 0. And here, if I plugged in a negative 2, negative 2 plus 2 is 0. There's my two solutions. Okay, I'd like you to pause the video and try this one without my help. That's your first homework assignment. So you can just put number 1, kind of box this, and then we'll check it tomorrow. All right, there's 2 other types that you can still try to factor. So if I look at this one, I'm still going to try to factor it, although some of you might be able to do this one in your head. I noticed that, hey, this is a perfect square, this is a perfect square, and it's the difference of perfect squares. Hopefully you're starting to notice these. So I'm going to try x and x. Okay, and then I've got 49. It's going to be 7 and 7. If it's negative 49, it's got to be 1 positive, 1 negative. Now I factored it. Okay. So now what would make this one equal 0 and what would make this one equal 0? Well, in my first parentheses, if I plugged in a negative 7, that would equal 0. And this one, if I plugged in a 7. All right, you guys are going to try the second one. That's one of your homework problems. So go ahead and put number 2. You can pause it, the video, try it right now if you want, or write it down, but you're going to need to have that one completed as well. All right, we have one last type of problem that we are going to try to solve. So you may notice, if you look at this one, looks a little different. This does not equal 0. If it equals 0, it's a lot easier to solve. Now you could use completing the square that we just learned, or we're going to try to solve this by factoring. So I want it to equal 0, so I can use the 0 product property. So since this is an equation, I can subtract 45 from each side. Okay, now I have 0 over here, and I have 25y squared minus 60y plus 36 equals 0. So our whole lesson is solved by factoring. So let's try to factor this. Now you might think, oh man, this is not going to be a nice one. But always look for perfect squares. Perfect square, perfect square. So I'm going to see if that will work. So I'm going to do a square root of 25 as, I don't know why I wrote a 2, is 5y times 5y. Square root of 36 is 6 times 6. And then I know when I add, I need negative. So it's probably going to be a negative times a negative. Gives me a positive here, negative when I add. Now I just double check. Right here, 6 times 5, our negative is negative 30. Here's another negative 30. That does make negative 60. So now if I look at this one, what could I put in here to make it 0 or in here? Well, you might notice it's the same exact thing. So you're going to get the same answer twice. So really just one answer. So if I do 5y minus 6, when does that equal 0? I'll add 6. I get 5y equals 6. Divide by 5. Y equals 6/5. And I would get that again. So there's only one solution to this one. All right, so I'm going to have you try 3 more problems. You might get stuck on them, but try your best. A little hint, try to get this to equal 0. And I would try to get everything on one side and then 0 on the other side, then try to factor it. We'll go through these tomorrow, so I'd like you to practice these, or try these 3 right now, along with the other 2 from the video. Then, again, remember, you need to screenshot everything that you wrote down today and submit it to Schoology.